Hi, my name is Mohamad Nasrul Azim bin Zaharul Ezri. Our group has chosen the title Geopolymer for this assignment. Geopolymer concrete is an innovative and eco-friendly alternative to traditional Portland cement concrete. Instead of Portland cement, it uses industrial byproduct like fly ash, slag, and methacholine combined with alkaline activator to form the hardened binder. They significantly reduce the carbon footprint in concrete production. Why is this important? The production of Portland cement contributes to about 8% of global CO2 emission due to its energy-intensive process. Geopolymer concrete eliminates this by using waste material, reducing emission and diverting byproduct from landfill. So what is the component of geopolymer concrete? Geopolymer concrete component is fly ash, slag, methacholine, which is industrial byproduct rich in aluminosilicate, alkaline activators, solution like sodium hydroxide and sodium silicate, which trigger the geopolymerization process. So, what is the advantage of this concrete? This concrete advantage is durability, better resistant to chemicals like sulfates and chloride. Number 2, strength, comparable or even superior to the traditional concrete, which is OPC concrete. Number 3, eco-friendliness, reduce CO2 emission and promote recycling. Number 4 is sustainability, reuse waste material and supporting green construction. In conclusion, geopolymer concrete is a sustainable, high-performance alternative that aligns with effort to reduce emission and promote environmental stewardship. Thank you.
Assalamualaikum, my name is Mohamad Aiman Bin Juzailan. I will be explaining the main components. So the number one is fly ash. It is a byproduct of coal combustion in power plant, commonly used due to its high reactivity and availability. Number two, we have GGBS, which is like ground granulated blast furnace slag, a byproduct of steel manufacturing, enhancing durability and strength. Methacholine and calcinite clay that provides high reactivity and improves early strength. Rice husk, ash, or silica fumes actually. And number two is we have the alkaline activators. We have sodium hydroxide, as well as sodium silicate. And then we have aggregate and water. Next, I'll be explaining about the manufacturing process. Number one, we have to prepare alkaline solution, dissolve sodium hydroxide in water to a specific concentration. Number two, we have to mix the ingredients, combine dry materials, and gradually add the alkaline solution and mix thoroughly. Number three, we have casting and compaction. Pour the mixture into molds, use vibration to temper to remove the air bubbles and compact the mixture. Number four, we have curing. We have heat curing and ambient curing. So heat curing placed in an oven for 60 and 90 Celsius for 20 to 48 hours. Ambient curing occurs when we don't really have the heat, the appliances to go for heat curing.
Assalamualaikum. I will proceed with the key properties of geopolymer concrete. First of all, geopolymer concrete has a high strength. Geopolymer concrete offers compressive strength comparable to or even higher than Portland cement concrete. Secondly, is low shrinkage. Geopolymer concrete experience minimal dry linkage due to its stable binder matrix. Thirdly, chemical resistant. Geopolymer concrete resistant to acid, sulfates, and other aggressive chemicals that have been attacked the normal Portland cement. Fourth, thermal resistant. Geopolymer concrete retain its strength and structural integrity at high temperature up to 800 till 1000 Celsius. Lastly, long-term durability. It has a dense microstructure, which is protect moisture ingress, freeze-thaw cycle, and carbonation. Next, I will discuss about environmental benefits of geopolymer concretes. First, geopolymer concretes reduce carbon footprint by producing geopolymer concretes can reduce CO2 emission up to 90%, making it greener alternative. Next is utilization of industrial waste. Geopolymer concrete used by product, so it's diverting this material from landfills and support the circular economy and reduce environmental pollution. Next is energy efficiency. Geopolymer concrete does not require high temperature calcination, saving substantial energy. Last from me is versatility in application. Geopolymer concrete has been suitable for infrastructure, marine structure, fireproof and heat-resistant structure, and precast element.
Okay, now I'm gonna continue with my part, which is the challenges and limitation for geopolymer concrete. Okay, first of all, the workability issues. Workability issue for geopolymer concrete, it tends to have a shorter setting time, which can make handling and placement more challenging, especially in a large-scale project. It's also highly sensitive to temperature and curing condition, which can complicate on-site application. The second is high cost of alkaline activators. The use of strong alkali activators such as sodium hydroxide and sodium silicate can pose for the safety hazards during handling and preparation. The cost is also can be expensive because it's can contributing to the initial cost compared to the traditional concrete. The third is structural application. The lack of standardized design codes and guideline restrict its adoption in critical infrastructure project. It's because it has a low demand and it was not the main component right now for the construction. Okay, fourth is curing requirement. GPC often requires specific curing condition such as elevated temperature, thermal curing, or controlled environment to achieve optimal strength. This limits its use in ambient temperature setting without additional adaptation. For the fifth is market acceptance. Market acceptance is limited the availability of commercial geopolymer concrete products and trained labor adds to the challenge. Lastly, the recycling and end of life. The recyclability of geopolymer concrete and its compatibility with, with existing recycling system are not as well studied as OPC concrete. Okay, that's all from me. Thank you.
Next, I will continue for application. The first one is infrastructure. High capacity strength made geopolymer concrete ideal for bridge, deck, beams, and column used in pavement layer due to its abrasion resistance and ability to withstand heavy loads. Second one is marine structure. Excellent chemical resistance to chloride, sulfate, and seawater make geopolymer concrete suitable for piers, deck, and seawall. The third one is fireproof burning and precast element. Inherent fire resistant up to 100 degrees Celsius make geopolymer concrete an excellent material for constructing fireproof wall, floor, and ceiling. So the conclusion, high performance. The first one is high performance geopolymer concrete offer excellent strength, durability, and resistance. Second one is versatile application. It is widely used in bridge, road, and airport pavement. The third one is sustainability by utilizing industrial byproduct like the fly ash and slag. It reduces dependency on Portland cement. And the last one is cost effectiveness. It long service life and reduce maintenance needs, lower overall life cycle cost. Thank you.